Okay, so today you guys should have been reviewing how to do long division with polynomials and synthetic division with polynomials. I know the notes were probably a little confusing, so I wanted to do a couple examples with you guys just to make sure that you understood the process with how to do long division. Now, one thing to remember is that long division with polynomials is just like long division with numbers. Of course, you have x's instead of numbers in there. That's the only big difference. So let's take a look at an example of us trying to divide polynomials. So let's say we have x cubed minus 1 all over x plus 1, which is the first example that you guys really went through on the sheet. So first of all, when you're doing these, you do the same setup as you would with normal division. You put what you're dividing by outside the house, and inside of it, you put what you're dividing. So this is going to be x cubed, and then make sure if you're missing terms, you put them as 0. So this will be plus 0x squared plus 0x minus 1, because you're missing the x squared and the x, put those in there as 0 as placeholders, basically, to hold those places. So now this is where it's a little bit different than regular division. We're basically going to ask ourselves, what do I have to multiply x by to get x cubed, the first term in here? So x times what gives me x cubed? Well, that's got to be x squared. So put x squared up here, and I always like to line it up with the x squared below, because then when I know when I get to the end here, I'm done. Then multiply through, so x squared times x is x cubed, and x squared times 1 is x squared. Now you're going to do the same thing you normally do with division. Once you put these down here, you subtract off what's below it. So these cancel, they're gone, and then you have 0x squared minus x squared, which is a negative x squared. So be really careful there. Then just like in normal division, you bring down the next term. So we're going to bring down the 0x and repeat that process. So again, you're going to ask yourself, what times x gives me a negative x squared this time? So what times x gives me negative x squared? That's going to be a negative x. So negative x times x is a negative x squared. Negative x times a positive 1 is a negative x. Again, just like in normal division, you're going to subtract off what you just put down there. So again, notice that these cancel, they always should. 0x minus a negative x is a positive x. Bring down the next term. And we probably have to do this one more time. So what times x gives me x? That's 1. 1 times x is x. 1 times 1 is 1. Subtract off that entire thing from the previous thing. So x minus x, those cancel. Negative 1 minus 1 is a negative 2. What you have here at the very end is the remainder. So when you're writing your solution, the whole number part is the x squared minus x plus 1. Plus, then you have the remainder, which is part of a fraction. So the numerator of the fraction is going to be the negative 2 all over what you were dividing by is the x plus 1. And that is what this divides into. So it's got a whole number part, the x squared minus x plus 1, and a fractional part because it does have a remainder. Okay, now, as you can probably imagine, long division is pretty tedious, but there are some times you're going to have to use it, but there's lots of times where you don't have to use it. In particular, you can get around using it if you have a division with a linear. So you can use what's called synthetic division anytime that you're dividing by a linear function. Okay, so this wouldn't work if you're dividing by like a quadratic or a cubic. So if your denominator is anything besides a line, you cannot use it. But if you have a line, which is what you do most of the time, you can actually use the synthetic division. So for example, if I do that exact same problem we just did with synthetic division, so x cubed minus 1 all over x plus 1, the first thing that you have to do when you're doing synthetic division is realize you have a line on the bottom, and when you're picking what to put on the shelf, there's this thing called the shelf here, you set the bottom equal to 0, and whatever makes the bottom equal to 0 is what you put on the shelf. So we're going to put negative 1 on the shelf. And then next to that, we're going to put the coefficients of the numerator. So you have 1x cubed, you have 0x squareds, you have 0x's, and then you have the negative 1 is your number term. So notice, just like with the long division, you need to put those zeros in there as placeholders for your missing terms. So now put a big horizontal bar down here, and your first step is always bring down this first term. So this first term is 1, bring him down. Then you're going to multiply that by what's on the shelf. So negative 1 times 1 is negative 1. Bring that over to the next column. Then you add these. And this is why I actually like this better than long division if I can avoid it. It's because you're adding, you're not subtracting. So 0 plus a negative 1 is negative 1. Now you do the same process. So you multiply what you just got by what's on the shelf. So negative 1 times negative 1 is a positive 1. add that column, you get 1. Again, multiply by what's on the shelf, so negative 1 times 1 is negative 1. Add that last column, you get negative 2. That number that spits out is your remainder. Okay, so notice we got the exact same remainder that we got before. And then here, the terms always go down by 1. So this is x squared, this is x, this is our number term, and that's the coefficients of those values. So this is going to be x squared, then you get the minus 1x plus 1, and then again you put your remainder over what you were dividing by. Look at that, we got the exact same answer, but in probably about a fraction of the time. But again, you can only use this if you're dividing by a linear. So let's take a look at one more of these. So let's say, for instance, we're dividing x cubed minus 4x squared plus 1, and we're dividing it by x minus 2. Okay, so first thing we realize we're dividing by a linear, so if we're dividing by a linear, we could do synthetic division. So set the bottom equal to 0. What makes that 0 is 2. Put that on the shelf. Then put in your coefficients. So you have 1x cubed, negative 4x squareds. Then you have 0 x's. Make sure you put that in there. And then you have 1 as the number. Put your horizontal line down there. And now bring down your first term, 1. And then multiply with what's on the shelf. So 2 times 1 is 2. Add, you get negative 2. Now take that number times 2. So 2 times negative 2 is negative 4. Add, you get negative 4. Again, multiply by what's on the shelf. Negative 4 times 2, you get negative 8. Add, you get negative 7. There's our remainder. So now write that out. This is your x squared. This is your x. This is your number term. Always reduce the power by 1. So you get x squared minus 2x minus 4 is your whole number part. But then you have that minus 7 over x minus 2 is the remainder. That's your extra piece. And that is what that divides out to be. Now, you don't just have to use that to find remainders. You can also use what's called synthetic substitution to find remainders. So you saw in your notes that you can find the remainder of, let's say we're doing 2x squared minus 3x plus 1 all over x minus 2. You can find that remainder by doing one of two things. You can do synthetic division, which wouldn't be too bad, so let's get a little practice with that. So put your 2 on the shelf, because that's what the denominator equals 0. You get 2x squared, so you got negative 3x's, and then you got your number term is 1. Bring down the 2. 2 times 2 is 4. Add, you get 1. 2 times 1 is 2. Add, you get 3. So I see my remainder is 3 by doing it that way. But you can also use what's called synthetic substitution, which in this case might not make it any better, but there's a lot of cases where it actually is going to be better. So if we want to find the remainder, all you have to do is substitute x equals 2 into the numerator, and you'll get the exact same answer. So if I do that, I get 2 times 2 squared minus 3 times 2 plus 1. You get 8 minus 6 plus 1. You get 2 plus 1. You get 3. So there's a couple ways you can get the remainder, and it's really helpful if you do a problem like this. So for instance, I want to find the remainder of x to the 100th minus 1 all over x, let's do x plus 1. I would be plugging negative 1 into that. So negative 1 to the 100th minus 1 using synthetic substitution. I see I get positive 1 minus 1, which is 0. Okay, so I got the remainder a heck of a lot quicker than if I tried to do this. I'd have to have 1 and then like 99 zeros and a negative 1. I have to do synthetic division a million times. So we're going to try to avoid that, and anytime you have huge numbers like this, you want to actually use the synthetic substitution. Now the last little bit you should have picked up on in the notes is, what if you get a remainder of 0 here? What that tells you, for instance, in this problem, is that this guy is a factor of x to the 100th minus 1. So if I wanted to factor x to the 100th minus 1, one of the factors is x plus 1. That's what that tells me. So that's what the factor theorem says. It says if a polynomial has a factor x minus k, it only works if when you divide, you get it 0. So for instance, if we want to show that something's a factor, we just have to show if the remainder is equal to 0. So for instance, if we ask the question, is x minus 1 a factor of 3x cubed plus 5x squared minus 1. All we'd have to do is show that the remainder is 0 if it is a factor. If it's not equal to 0, it's not a factor. So let's do a little bit of synthetic division. So I'm going to put 1 on the shelf, or you can use synthetic substitution. Okay, that'll work well here. So we have 3, 5, we have 0 x's, we have negative 1. Okay, so this is our x cubed, or x squared, or x in our number term. Bring down the 3, 1 times 3 is 3, add you get 8, 1 times 8 is 8, add you get 8, 1 times 8 is 8, add you get 7. As soon as I see the remainder not 0, this is not a factor. So we just found out that x minus 1 is not a factor of our original polynomial. Okay, let's take a look at one more. So let's say, for example, we want to see is 2x plus 1 a factor of 2x squared plus 5x plus 2. And again, if you want to, you can use synthetic substitution. I'm going to use synthetic division. A little bit careful here. When you set this equal to 0 to find what you put on the shelf, you're going to get 2x equals negative 1, so x equals negative 1/2. It is okay to have fractions on the shelf. There's nothing weird about that. So negative 1/2, we got 2x squared, we got 5x's, we got 2 as a number. Bring down your 2. Negative 1/2 times 2 is negative 1. Add, you get 4. Negative 1/2 times 4, you get negative 2. Add, you get 0. So we got a remainder of 0, which is telling me that 2x plus 1 is a factor of 2x squared plus 5x plus 2. So if I factor it, this is going to be one of your two factors for that quadratic. Alright, so hopefully that helps you guys get through what you're supposed to get through with the notes today with the sub. Please drop by in the morning if you have any questions, and see how tonight's homework goes. Alright, talk to you later, guys.